This is our yew tree, and as you can see, it's full of pollen. And I'm going to take a few samples of this, shake it practically on the slide, and add a little water so they become transparent, and study them under the microscope. And let's see what we find. So I've now taken the pollen sample. I put it on the microscope slide. I've added a little bit of water. And let's turn this microscope on and look through the lens. This is a binocular, so I will see it with binovision.
But I wonder what you could fix them in. No, you might be able to fix them. Do you know that?
Yeah, with the balsamic, with the balsam, kind of balsam.
Well, you could fix it, but I was thinking of fixing it in gradient alcohol. Just make 50, 75, and then 100. That's what we used to do.
You can do it.
Be faithful. Should go a very long way. And that henna could last years, and the balsam should last years. Now this is the stuff that's we'll give you a quantity of it, but you want to look at, but you can look at all sorts of things.
And when I showed this slide, the image that I take from this part of it, to my wife, she immediately pointed to this pollen and something inside it. That is a dividing chromosome of a U3 pollen. That's amazing. She was so clever. She showed it to me. They are at different stages of the division, and this one was actually developed in very good way. That is the reason the pollens are so numerous, because they all the time are dividing, and that's the reason, because of the number of them, they cause interaction with our nose, with our lungs, and cause allergic reactions in us. And this is one of those ways that they actually do this, by sheer number of them.